Let's test to see how many spiral-shaped objects you can find around you right now. I'll bet there's more than you think. A spiral may be hidden in the flower petals of your houseplants. One might be staring at you from that seashell you brought home from your last trip to the beach. If none of these objects sound familiar, you might want to head over to the mirror and turn to the side a bit. In case you haven't noticed yet, even our own ears are shaped like a spiral. Why does Mother Nature seem to have such a preference for this shape? Many theories wish to explain this weird behavior. One of them is based on the Fibonacci sequence. This Italian mathematician didn't really care much for spirals initially. He was studying rabbits when he came up with this theory. Fibonacci came up with the sequence as a solution to a problem involving the growth of a population of rabbits. Let's recreate his experiment. If you put a pair of rabbits in an enclosed space, how many pairs of rabbits will you find there after a year? To solve this problem, Fibonacci proposed some conditions for his theoretical experiment: that all rabbits are born as a pair, one male, one female. Also, the rabbits can start reproducing after 1 month. More so, each pair of rabbits produces one pair of offspring each month. And lastly, none of the rabbits kicks the bucket at the end of the year. Now, using these assumptions, Fibonacci noticed the following sequence: 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and so on. The first two numbers in the sequence, 1, 1, represent the initial pair of rabbits. The next number, 2, represents the number of pairs of rabbits after the first month, one pair of the initial rabbits plus one pair of offspring. The fourth number, 3, represents the number of pairs after the second month, 2 pairs of the initial rabbits plus one pair of offspring, and so on. He soon noticed that his series is made out of numbers in which each number is the sum of the previous two numbers. A lot of other mathematicians have looked at this sequence over the years. They were soon surprised to discover that this system was found in many natural structures, such as the arrangement of leaves on a stem and the arrangements of seeds on a sunflower. If you don't understand why it is so, then grab a piece of paper and a pen. Together, let's try to draw the Fibonacci spiral. You'll have to start with a small circle at the center of your page and then draw larger circles around it without lifting the pen from the paper, using the numbers from the Fibonacci sequence. For example, the first circle is 0 units wide, the second circle is 1 unit wide, the third circle is 1 unit wide, and so on. As you keep adding more circles, they will fit together perfectly to form a spiral shape. The spiral gets bigger and bigger, but it always follows the same pattern based on the Fibonacci sequence. Another famous spiralist was a man named James Bell Pettigrew. He was a Scottish naturalist that became fascinated by the mystery of the spiral shape, which he noticed almost everywhere in nature. He studied it at all scales, from giant nebulae in space to tiny molecules. Despite his research, he couldn't figure out where the spiral came from. He was sure that it couldn't be just a physical thing, and he believed that organs in plants and animals are not only shaped like spirals, but they also work in a spiral way. At the center of lifetime work on this unique shape was the human heart. Pettigrew believed that the heart's spiral structure was the mystery of all mysteries. He also thought this shape was to blame for both its muscular contractions and how the blood seemed to travel within our mighty tickers. The reason why the spiral seems to be everywhere might be really simple: efficiency. Take a look at the basic sunflower, for example. It figured out a way to display its seeds so that it could expose them to the sun equally, without wasting any space and without being limited in their growth. Spiral stairs are another great example too. They just work better. You find it easier to climb them, and they should take less space than the usual ones. We also might be more inclined to notice this shape more than others. That's because a spiral shape, or its proportions, is more aesthetically pleasing to the human eye. It's the reason why interior designers, artists, or illustrators often use these principles in their work. The spiral symbol is also the oldest symbol found in every civilized continent. Some historians believe that the spiral in Asian art may represent the sun, as it has been found on roof tiles from the Tang Dynasty near the ancient city of Chang'an. It is also often found at burial sites, and scientists believe it to represent the circle of life, how we pass on and somehow be reborn. This is probably because in some ancient civilizations, people believed that the sun was born each day, extinguished itself each night, and was reborn the next day. You might have also stumbled upon the spiral as a symbol of hypnosis and dizziness. There's no real evidence that you can hypnotize someone by making them stare into a spiral for a certain time. But its effects on our abilities to focus and our optic nerves are significant. After you've stared at a spinning spiral for quite some time, you'll notice how objects either get smaller or bigger, depending on the direction of the spiral. It's easy to understand why some experience the sensation as hypnotizing. One of the most distinctive features of DNA is its spiral shape. It's also called a double helix. The double helix is formed when two strands of DNA twist around each other, like a ladder being twisted into a spiral shape. This spiral shape is important for many reasons. First, the spiral shape allows DNA to be compact and efficient. The double helix can pack a lot of genetic information into a small space, making it possible for cells to store vast amounts of genetic material in a small area. Second, the spiral shape allows DNA to be flexible and respond to changes in our environment. Because the double helix is made up of two strands that can move relative to each other, our DNA can change its shape. Finally, the spiral shape of DNA allows it to interact with other molecules in the cell. Now, let's look at the big picture. The biggest of them all, that of the galaxies found in our universe. They're also shaped like a spiral due to their rotation and the presence of dark matter. As the galaxy spins, the stars and gas clouds within the galaxy move in a circular direction around its center. This movement creates a spiral shape as the stars and gas clouds are drawn toward the center of the whole system. Additionally, the presence of dark matter, which is a type of matter that does not interact with light, creates gravitational forces that help to shape the galaxy into a spiral. But you don't need to look that far to understand why spirals are important. Your handy corkscrew is shaped like a spiral too, because it makes it easier for you to open the wine bottle. That screw you drilled into the wall to hang a picture, also a spiral. It helps it with some added grip and stability. Got a notebook on your desk? Those pages might be held together by a spiraled wire. It makes it easier for you to browse the notebook without damaging the pages. Even your hair strands might have a curled shape. The curlier the hair, the drier it will be. It means it will get sebum from the scalp down on the strand slower, making it easier to maintain and clean. And before I spiral out of control, we're done here.
Why do we love Saturn so much? Right, because we love its amazing rings. The planet stands out in the solar system because of them. The major rings have a diameter of 170,000 miles, yet their thickness does not exceed 330 feet. Saturn's slowest outermost ring spins at about 37,000 miles per hour. It's slower than the rotation of Saturn itself. But did you know that Saturn was ringless for most of its history? Let's find out how they were formed. Using Cassini's final plunge into the planet, researchers could estimate the ring's mass, 33 billion pounds. Further, they have determined that the rings were between 10 to 100 million years old, much younger than the planet itself. The thing is that the rings only look solid. They are made of billions of rock and ice chunks. They are primarily tiny ones, looking like grains of sugar to those as large as a house, or even as mountains. The innermost chunks of ice and rock shoot through space at about 52,000 miles per hour. There are mysterious spokes in its rings. It seems they form and disperse within a couple of hours, and these spokes might consist of electrically charged sheets of tiny particles formed when small meteors hit the rings, or maybe electron beams from Saturn's lightning. One theory says Saturn's rings have formed all that extra material that remained after Saturn began, which is a material that couldn't create a moon. There's also a theory that says there was Theia, a Mars-sized planet that collided with Earth about 4.5 billion years ago. Lighter crust parts ended up in space during the impact, whereas its denser core stayed behind. But in the case of Saturn, all that debris perhaps didn't put a new moon together, but it formed rings many people today recognize this planet for. Another theory is that rings formed from dust and debris of a moon that ended up destroyed by this big impact, maybe by an asteroid or comet. Or perhaps the rings are there because once a moon fell apart because of the tidal forces coming from its parent planet itself. If these rings formed at the same period as Saturn did, they would have had more than 4 billion years to collect a bit of debris and dirt coming from micrometeorite collisions. But these rings mainly consist of water ice, no dirt at all, which means they're younger than expected. And the nature of this ring system tells us a thing or two about Saturn's fuzzy inside. Fuzzy means its core is like sludge. The helium and hydrogen in Saturn mix with more and more rock and ice over time the closer you go to the planet's core. It's similar to what you see in our oceans. The deeper you go, the level of saltiness increases. But the rings may disappear in the far future. Rings are generally more common than we think. Jupiter, Uranus, and Neptune all have their own ring system. But not every planet has the same ones. Saturn has a fascinating halo, and definitely the most spectacular rings, true. Others mostly have rings made of dust and rocky particles, and not just planets. Other space bodies can have rings, like the asteroid called Chariklo. But even though the gas giants of our solar system have rings, rocky or so-called terrestrial ones don't. And one theory says it might have been that way because gas planets in the outer area of the solar system protected those rocky ones that formed in the inner solar system from all those collisions that possibly could have formed rings around them. Or it could be because gas giants are way bigger and their enormous volume allows them to have a ring system that can remain stable. And what if Earth had rings in the past too? Maybe in the time of the big collision when our moon could have been formed. Now to some more cool things happening in our solar system. Pluto, a tiny dwarf planet at the edge of our solar system, also the one we used to call a planet, has a pretty bizarre atmosphere. No one expected to see a haze there go as high as 1,000 miles. That means it rises higher above the surface of the atmosphere of our home planet. And the atmosphere on Pluto has around 20 layers. They're more compact and way cooler than scientists expected, and tons of nitrogen gas escape Pluto by the hour. But the dwarf planet still finds a way to constantly create new supplies of all the nitrogen it had lost. One theory says it probably produces these supplies through geological activity. Our moon is pretty peaceful, but that's not something we can say for Io, one of Jupiter's moons. This one has hundreds of volcanoes. It's the moon with the most volcanic activity in our solar system. Io sends plumes of sulfur up to an incredible 190 miles into its atmosphere. Its volcanoes emit many particles and gases into the space right next to Jupiter every single second. Its eruptive activities happen because of Jupiter's mighty gravitational forces and magnetic field. The insides of Io tense up and relax all the time, depending on how close or far away it is from Jupiter. And that's why it generates enough energy to have such an eruptive nature. Speaking of volcanoes, Mars has one larger than the whole state of Hawaii. At first, you'd probably say it's a quiet and peaceful planet. But once upon a time, enormous volcanoes dominated its surface. Yup, that includes a well-known Olympus Mons, the largest volcano ever found in our entire solar system, 374 miles across, comparable to the size of Arizona. Olympus Mons is 16 miles high, 3 times the height of our tallest mountain, Mount Everest. And by its volume, this volcano is 100 times bigger than the largest one on Earth. Mars can have such big volcanoes because its gravity is significantly weaker than the one on our home planet. Also, the crust on Earth moves all the time, unlike the Martian crust. Do you know how the Hawaiian Islands formed? A hot spot in the mantle created a chain of volcanoes in the crust floating above it. A Martian volcano may grow bigger because its surface isn't moving, so a volcano could build up for a longer time in just one spot. Miranda is one of the most bizarre moons in the outer part of our solar system. It's a shadowy moon that orbits Uranus, with many craters, sharp ridges, and similar disruptions on its surface. Usually, this type of relief tells a certain area used to have a lot of volcanic activities. But that wasn't the case with Miranda. Also, this moon is way too small to generate tectonic activities. Another element that could form this type of surface. One theory says the gravitational force from Uranus could have caused the push-pull action, something that made all these bumps on Miranda's surface. We'll have to send another spacecraft to find out what was happening there. We are all made of stardust. 97% of atoms we're made of are the same as the material our galaxy consists of. The building blocks of life is a term we use for a group of elements that are vital for life on Earth. And stars have these elements too, but in different proportions. For instance, we are 65% oxygen by our mass, whereas elements we measure in space, like the spectra of stars, have less than 1% of oxygen. So, Mercury is already the smallest in our solar system in the planet category, excluding some other bodies like the dwarf planet Pluto. And now it looks like it's still shrinking. It's the second densest after our planet, but it's getting denser over time. Researchers thought the Earth was the only planet in our solar system with tectonic activities for a long time. And now we know Mercury is tectonically active too. Messenger spacecraft managed to map the whole planet. Scientists realized the planet is full of fault scarps, some cliff-like landforms. Since these are relatively small, they're probably young, and Mercury is still contracting even 4.5 billion years after our solar system was formed.
Now, let's pretend that humanity faces a huge threat from outer space. So we'll imagine that a giant planet-eating octopus comes to our solar system to eat Venus, Mars, Earth, Jupiter, and other planets, except Saturn. Therefore, people decide to move to the big planet with giant rings. Fortunately, they already have cool technologies that allow them to make such trips. So we get into giant ships, take off, and fly to Saturn. Life on the planet itself is impossible because it has no solid ground. The ship won't be able to land there. This is a giant gas ball that is 9 times wider than Earth. To compare their sizes, look at a 5-cent coin and a baseball. And the planet's atmosphere consists mainly of hydrogen and helium. So if the ship starts to land, it'll never reach solid ground. And the lower it goes, the higher the pressure it will experience. Eventually, the ship will just be crushed. Therefore, we have only one choice: the rings of Saturn. They're made up of giant, medium-sized, and tiny particles of ice and rock flying around the gas giant at tremendous speed. They were formed from comets flying by. Saturn's gravity knocked these celestial bodies off their course and crushed them with its pressure. Fragments of these comets began to accumulate around Saturn, forming rings. Now, some of these particles fly faster, some are slower. The closest to the planet is the D ring. It's followed by rings C and B. Then there's a large gap called Cassini division. Rings A, F, G, and E come after. This classification is very convenient for creating a ring map. So, people approach the rings, but don't dare to land on them. First, they send test capsules with robots to scout the area. The robots choose a suitable location on the E ring. In fact, the distance between the rocks is quite large, and the ship can easily fly there. There are tiny particles, huge rocks the size of houses, and comets the size of a whole mountain. The first robot flies up to a large rock at high speed. At this moment, a baseball-sized stone pierces the robot's body. Another robot gets smashed between 2 colliding boulders. The third robot gets caught in a rain of sharp icicles and breaks. People have big engineering workshops on their ships, so they build new capsules and new robots. This time they're made of more durable materials, so the robots reach a big rock again. A few particles crash into them, but don't break through the armor. The machine set up a small station on a flying rock where people can live. But after a couple of hours, a big chunk of asteroids smashes the station. Well, Seems like we need another strategy. Giant ships scan the entire area of the E-ring and calculate the trajectories of billions of stones. After lengthy calculations, people finally find the perfect places in the middle of this chaos that will stay intact for a long time. They land on these large rocks in their capsules and begin to settle down. They build stations and small houses and install powerful batteries on them. Saturn is located at a distance of 9.5 astronomical units from the Sun. 1 unit is the distance from the Sun to Earth. So, Saturn is a pretty cold place. That's why there's so much ice flying around it. But how to get the energy to heat it all up? There's too little of it on large ships. Besides, solar panels are ineffective here because of the great distance from the Sun. Therefore, scientists create a way to generate kinetic energy from flying stones. It's like a windmill. When the wind drives the fans, these movements are converted into energy. So engineers build panels that collect power from the moving stones. But it doesn't slow the speed of rocks down because Saturn's gravity continues to move them. Thus, people receive a source of almost limitless energy. Some space stations have plants and trees that produce oxygen through photosynthesis. Only instead of sunlight, they get energy from ultraviolet. Then, people fill large tanks with oxygen and carry them to their homes. People begin to occupy the adjacent rings. You don't need a lot of fuel to get from one place to another. You can land on a rock, calculate its route, and wait for it to bring you to the needed point. Then you can move to another one, and so on, until you reach your destination. More and more people leave their ships and move to the rings. It seems that life is getting better, but then psychological problems begin. Constant movement in the vacuum of space drives everyone mad. Imagine living on a carousel that never stops. You can't walk to the store whenever you want because it always flies away. No one can go out for a walk, even in a spacesuit, because there's a chance to come across a rock flying at high speed. You can't plan anything because, at the moment, your plans can be ruined by a giant piece of ice. Computers don't help either. They can't calculate the trajectories of all space bodies. Rocks tend to break and split into hundreds of smaller ones. Also, new comets fly by and also become part of the rings. All this creates uncertainty and causes a sense of anxiety in people. Besides, it's dark, cold, and very lonely on the rings. Now think about building a base on a space object, but your best friend lands on another one a few miles away. Then, a giant icicle crashes into his rock and increases its speed. And a few days later, your friend is too far away. And it happens all the time. The only way to change your life is to settle on one of Saturn's moons. The planet has 83 of them. People have already confirmed and named 63, and the existence of 20 others has yet to be confirmed. They're all like different worlds. Some of them may be habitable, and the best candidate among them is Titan. There may be water on it, and its atmospheric pressure is only 1.5 times greater than Earth's. Its atmosphere consists of nitrogen and a little methane, forming carbon smog in Titan's upper layers. For this reason, we can't study this moon from Earth. But the coolest thing is that Titan flies outside the rings of Saturn. This means people can lead a quiet life there. There's also satellite Phoebe, covered with craters like our moon. This giant celestial body looks more like a gigantic meteorite. People have a lot of choices of where to start a new life. During a couple of 100 years spent on ships near Saturn, humanity would learn everything about its satellites. But why did they try to live on the rings? Why didn't they land on one of the moons from the very beginning? Because, well, then this video would be less fun and a whole lot shorter. But what if we were initially born inside the rings of Saturn? Let's say a massive meteorite with frozen water got caught by the planet's gravity. There were the simplest life forms inside the ice, and then this life began to acquire more developed forms. Imagine that the large rock managed to remain untouched for hundreds of millions of years, and during this time, humans appeared. But of course, they would be very different there. Firstly, they wouldn't experience gravitational forces. This would make them taller, but weaker. People's skin would be pale because of the lack of light. but very hardy thanks to cold temperatures. Particles of ice and grains of sand flying in space would roughen people's skin. In such biological armor, without gravity, they would jump from one rock to another in search of food and water. And, by the way, that would be the main problem. How would people survive without oxygen in the vacuum of space? Where would they get their food? Saturn's rings are a pretty lifeless and dangerous place. If there are not even the simplest forms of life there, then how could such a complex one as the human appear? Therefore, even in theory, the appearance of people would be impossible there.